Hello everyone. Let's solve one more question from EMT. The question is a linear diatomic molecule consists of two identical small electric dipoles with an equilibrium separation R, which is assumed to be constant. Each dipole has a charge plus minus q of mass m separated by distance r. Here see two dipoles. When the molecule is at equilibrium, each dipole can execute simple harmonic motion with frequency omega. And here also hint given that recall that the interaction potential between two dipole is P1 P2 minus 3 P1 dot n cap whole into P2 dot n cap divided by 4 pi epsilon R1 to whole cube. Okay, and R is much greater than R, that is the distance between two dipole is very greater than the separation between two charges. Okay, and here omega square value is given. The angular frequencies of small oscillations of the diatomic molecule we have to find out, and this is SHM question, so you know you have to equate the force, so that force with minus m omega square x, so that we can find out our desired angular frequency. See here two dipoles plus minus two dipoles separation distance is r, and the distance capital R is in between the two dipoles. So the potential energy, and this is also identical. So P1 vector mod is equal to P2 vector mod. That is P. P is the dipole moment. Dipole moment same. So here energy is P into P minus 3 P. P1 dot n cap is P whole into P2 dot n cap is also P divided by 4 pi epsilon naught R12 square. You can write that R12 Q, you can write is RQ. So total energy, interaction energy is P square minus 3P square divided by 4 pi epsilon naught RQ, and that is minus 2P square divided by 4 pi epsilon naught RQ. You know the force is negative grad of potential energy. And see here I am doing the derivative with respect to R. Minus del F by del R, if you do, then that will be minus 2P square divided by 4 pi epsilon naught 4 pi epsilon naught, sorry, not R is constant, we can derive with this. See P is equal to QD, and the distance D is the this distance between the two charges, so that will be QR. So potential energy is equal to minus 2 Q square R square divided by 4 pi epsilon naught RQ. If you do derivative with respect to R, then that will be minus 4 Q square R divided by 4 pi epsilon naught RQ, and 4 get cancelled, minus Q square small r divided by pi epsilon naught RQ, and force is minus m omega square R, because m is the mass, A is the acceleration, A is the omega square R, you know. Okay, and then minus q square R divided by pi epsilon naught RQ, and RR get cancelled, minus get plus, so omega is the q square divided by pi epsilon naught m RQ is omega. Okay, but in here question this omega is q square by 4 pi epsilon naught m r cube. So that will be q square. If you multiply 4 and divided by 4, then that omega will come. So that will be 4 omega square, if that is omega square. So our before interaction between dipoles, our omega naught is omega naught is the angular frequency of before interaction, and here omega is the angular frequency of after interaction. Okay, after that is angular frequency. Then the net omega will be omega naught square plus omega square whole root. Okay, that is omega naught square plus minus you can say. So plus minus 4 omega square whole root. So this is the option C, you can see. This is not efficient method, but I am trying my best to do like this. Okay, so thank you. Keep watching.